Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have already discussed about what is atmospheric pressure. I think you have got an idea about atmospheric pressure. The thrust exerted by the air column on unit area of the earth's surface can be regarded as atmospheric pressure. And we have also seen yesterday that how actually we can get a measure of the atmospheric pressure. Now, question might be arising that we have drawn the figure on the previous class. Now, question might be arising in your mind that how can we get the value of atmospheric pressure from that arrangement? Okay. So, for information, let me just recapitulate that particular arrangement is called the simple barometer, with which you can actually get an estimate value of the atmospheric pressure, the pressure exerted by the Earth's atmosphere. So just let us redraw the diagram. If we consider an open trough like this, and there is already mercury present in this trough, so mercury is already present in this trough. We are just drawing the diagram once again. If you have not watched the previous video about atmospheric pressure, please do see it. Otherwise, it will be difficult to get the full concept about the calculations that we will be doing today. Okay, so if I just insert a U tube, if we just insert a tube in inverted position like this, okay, inverted position like this, then it is observed that the mercury keeps on rising. Why? Because the mercury keeps on rising because the open surface of the mercury, atmospheric pressure is being exerted. Okay, this atmospheric pressure causes the mercury to move up, isn't it? The open surface, the atmospheric pressure that is acting on the open surface causes the mercury to move up. Okay, so here atmospheric pressure is exerted, and this atmospheric pressure causes the mercury to rise up. Now it has been seen that the mercury rises up to a certain height, and that height is basically, it has been observed to be 76 centimeter, or around you can say also 75 centimeters in most of the cases at normal sea level. Okay, not in high altitude regions or very low region places, rather at sea level it is seen that the mercury rises to 76 centimeter of the in this test tube. Okay, in this inverted test tube. Fine. Now there is a slight empty space above the mercury that has risen in the tube, and this space is called Torricellian vacuum. This empty space, or rather you can say little bit vacuum space, is called Torricellian vacuum. Torricellian vacuum. Okay. Why? Because Torricellian vacuum? Because Torricelli was the person who designed this kind of arrangement to determine the atmospheric pressure, and so in his name, in his honor, the vacuum space or the empty space left above is named as Torricellian vacuum. Okay, fine. Now see what happens. How can we get a value of the atmospheric pressure in terms of Pascal? As because we know that Pascal is the SI unit of pressure. Now let us see. I think you will be recalling that the pressure exerted by liquid column is given by the formula P equals to H rho G, where H is the height of the liquid column, rho is the density of the liquid, and G is the acceleration due to gravity. Now, when it is rising to 76 cm, why it is rising up to 76 cm? Because when it is rising up to 76 cm, the pressure exerted by this mercury column will be such that it balances the atmospheric pressure. So basically, if we calculate the value of this pressure exerted by the mercury column of 76 cm height, we can actually get the value of the atmospheric pressure. So let us see the calculations. So if I do the calculation, pressure exerted by the mercury column, so height up to which, so the formula is basically H into rho into G. So the height up to which the mercury rises is 76 centimeter. So converting into meter, it is 0.76 meter into what will be the density of mercury in SI unit. In CGS unit it is 13.6 gram per centimeter cube. So in SI units we will be just multiplying 1000 with it. So 13.6 into 10 to the power 3 kg per meter cube. We are taking all this in SI unit because then the value of the pressure that you will be getting, it will be in SI unit, Pascal. and acceleration due to gravity is generally 9.8 meter per second square. Now when you multiply this value, but the value we are getting is in Pascal, and if you do the calculations and if you just can cross check the calculations, the value will be coming out to be something like this: 1.01 into 10 to the power 5 Pascal. Okay, so actually the atmospheric pressure that is being exerted on the earth's surface is having a value of 1.01 into 10 to the power 5 Pascal. We can just simplify it. We can just simplify it to be 1 into 10 to the power 5 Pascal, or you can simply say that the atmospheric pressure is about 10 to the power 5 Pascal. You can also say this value. Okay, it's nothing wrong. So this is the average atmospheric pressure that is being exerted by the atmosphere at normal sea level. Okay, so have you imagined how much thrust is being exerted on a human body by the atmosphere? Have you ever imagined? Okay, just let us do the calculations. We will see the value. We know that thrust exerted. So I think this calculation is clear. If not, please pause the video, move back a little, watch the video once again. The calculations will be clear. So I hope you have understood how we can get the value of the atmospheric pressure using a simple barometer. Okay. Now the question that I was talking about, that have you imagined what is the thrust exerted by the atmosphere on your body? Have you ever imagined? It has been seen that on an average, it is seen that the surface area of human body is about 2 meters square. Okay. Now we know that thrust is basically the force exerted perpendicularly, and that thrust is equals to pressure into surface area. So the pressure is about 1 into 10 to the power 5 Pascal. Area is 2 meters square. So how much is the value coming out? 2. Then we will be adding 5 more zeros. This much Newton is the thrust exerted by the atmosphere on our body. Okay, so can you imagine? It's a huge value, but still we do not feel this value. Why? That isn't, you know why? Basically, we are accustomed to this high pressure or high thrust from our very childhood, so we get accustomed to this, we get habituated to this. In other words, you can also explain it like this, that the blood which is running in our body is also exerting certain pressure from inside. Now the atmospheric pressure is being balanced by the blood pressure which is running through our blood vessels. So basically that blood pressure balances and nullifies the pressure exerted by the atmosphere on us, and in this way you can say that we are not feeling the pressure exerted by the atmosphere. Okay, so this is the simple calculation. Okay, so I hope the conversation is clear and the calculations are clear. Okay, so there are two more instruments by which we can measure the atmospheric pressure. One is the Fortin's barometer and another one is the aneroid barometer. Okay, so basically Fortin's barometer or aneroid barometer are slight modifications of this simple instrument. Okay, this simple barometer. The Fortin barometer is almost similar to the simple barometer that we are using. Simply, in case of Fortin barometer, there is a wooden casing. In simple barometer, it is an open system. So there is a possibility that dust particles fall onto the mercury, they get mixed up, and they can actually, the mercury barometer, simple mercury barometer can give false calculation or false values in some cases if impurities get mixed up with it. So it may be possible. So in those cases we use Fortin barometer, which is more portable, it is well covered, and it is actually a well protected system, so that we can easily move from one place to another place. We can easily use it to measure the atmospheric pressure at any place, and you can move it from one place to another with much casual approach. Okay, fine. Another thing that we want to talk of is that have you ever imagined that why we do not use water to measure this atmospheric pressure? Now, this is a very good question. If you just think of it, why we do not use water to measure the atmospheric pressure. Why we do not use water? Have you any idea? See, we know that the pressure, the value of the pressure was given by P equals to H rho G. So we take water, then we do not know up to how much height the water will rise. Okay. So if I just compare the both the cases using if I just use one barometer in which we have used water and you take another barometer while we use mercury, I think we can equate those two pressures like this. So pressure exerted by mercury column will be equal to pressure exerted by water column, isn't it? Now actually we do not know what height up to which the water will go up and balance the atmospheric pressure. That is the main problem. So we are just trying to figure out what height up to which the water will go up. For this we have to put the value of the corresponding values H rho G. So mercury rises up to height of 76 centimeter or 0.76 meter. Okay. This multiplied by density of mercury 13.6 into 10 to the power 3 and multiplied by G. So this will be equal to the pressure exerted by the water. We do not know up to how much height it will rise, so let it be H dash into the density of water is 1000 or 10 to the power 3. You can simply write 10 to the power 3 kg per meter cube into G. So G gets cancelled out. Okay, this 10 to the power 3 10 to the power gets cancelled out. So this H dash will be equal to 13.6 into 0.76. So this calculation, if you do the calculation, this calculation almost turns out to be something like 10 meter, almost 10 meter. Okay. So have you ever imagined that if we have to take a test tube of height say 10 meter, so it's almost like that of, it's a huge value, isn't it? It's a huge value. So we cannot design a test tube having a height of 10 meter, a U-shaped test tube having a height of 10 meter. So basically it is quite difficult to measure the atmospheric pressure using water as the barometric liquid. Okay, I think so the concept is clear. The explanation, I think we have done it mathematically also, so it is easier for you to understand. Okay, so today we will be ending our class here. We will be discussing briefly about the Fortin's barometer and Android barometer in the next class. Okay, so till then please do study well. If you have any query, do mention it in the comment box. We will be happy to solve your problem. Till then, thank you. Goodbye.